Okay, so this is a quick tutorial on pre-design simulation using Revit. So we are going to start up a brand new scene. So I'm using the default template. And the simulation tools we are going to use are basically from Insight. So we're going to be working through this panel right here, which is going to do our simulation in the cloud. And as a starting point, what we need to use are massing models. So I'm going to go to Component, Model in Place, and I'm going to select Mass. And this is important. Have to select Mass as my family category. So I'm going to select OK and Close. And if you're following along the tutorials from my 222 class, you know that we are dealing with a very small microhome that is in the 20 by 12 range of its overall size. So using my mass tools, I'm basically drawing out that rectangle. If I look at that in 3 dimensions, I can see that those are joined to form a plane. And with the massing tools, I can click Create Form. I need to extend that form up to a reasonable height. 7 feet would not be a reasonable height for a microhouse. So let's just go ahead and make it a little bit tall. Maybe it'll have sort of a half loft in it or something like that. 12 feet. So this is the basic form that I want to run some basic energy simulations on for my given location. So let's go ahead and select Finish Mass. And the next thing that we're going to do, we need to identify this not as just a generic object, but as an actual building form. So to do that with the object selected, you will notice this mass floor tool is an option. And essentially what that's going to do is say within this massing form, in this case, if I click this, I will have a singular level at level 1. That's level 1 in my Revit scene. Obviously, if we went taller and had lots of levels, I could do an entire skyscraper with this sort of pre-design simulation thinking. But in this case, we're keeping it simple. Micro house, 1 level, and OK. So just in doing that, I know that I now have something that is identifiable as a building that we can run a simulation on. So going to the Analyze tab, we're essentially going to work through this set of tools. And because we're early in the process, we get to skip quite a few of them. So the first thing I need to do is select a location. So in this particular project, what I've been working on is this really cool site in the Redwoods as an experimental location. So I am copying and pasting my latitude and longitude directly from Google Earth. What I just deleted there was the height above sea level. So that's my latitude, longitude. I can select search. And I want to verify the weather station to use. This is very coastal, this particular location. So inland probably has more of an effect on the microclimate. I probably want this sort of pure weather data that's out in the ocean just a bit. So I am going to use that as my weather station. So I'm going to select OK to that. So my location is set, so I'm pulling in the correct weather data. The next thing that I want to do is go to my systems analysis. And what it's going to ask me here is create the energy analytical model. Yes, I do want to do that. I'm not going to run this analysis specifically, though. What I want to do is underneath settings and other options, I do want to set this building type because that matters. I'm going to change my building type from office. And this is the only place inside of Revit that I've found that I can do this. But I want to set my building type to single family. HVAC systems, all those things, when I get to Insight, I can make those edits once I'm at that location. But this isn't something that I can change anywhere in Insight and see its impact. So we're going to make that change here and say OK. and OK, and then cancel on running that analysis. Because what we really want is to generate this system analysis right here. So I'm going to click Generate, update the analytical model because I did just make a change. I'm not sure if it's going to make an impact, but if it does, I want it to. And I am going to click OK. So what's happening right now is that model is being uploaded into the cloud. So I will get my first email, which essentially says from Autodesk Insight, your model has been received. You will receive an email when the analysis is complete and you can access your results. So typically, if Amazon Web Services, which is what Autodesk uses, I'm assuming they still use that. If it's extremely busy, this might take anywhere from 10 minutes to 30 minutes. Often, in this case, it takes maybe 2 minutes or so. So I will be right back with this video once I have the Insight panel up. And just like that, the Autodesk analysis is complete. So what you're going to see is an email that looks something like this. Okay, your analysis is complete. You can access the results. View Insight. Click. So that is going to take me to a link. Well, let's see here. Let me close this up and select the link for my email. And we will slide this over in just a second once I get logged in. All right, so if I had saved my project, it would have my project title here, but it's just the default project 1 from Revit when I started. So you can see I simply have this sort of very plain vanilla box right here. I have my starting point, my benchmark, where I should be headed to my 2030 architectural challenge, my model history, and then I can start flipping these Insight tiles over. And again, this is a really small little thing. So the first tile, building orientation, you can see just doesn't have much of an impact at all in terms of energy performance, whether it's rotated, how it's orientated towards the north to south, east to west. But you can start to see windows do. The amount of windows in this location, actually the more windows given this environment, better the energy savings, especially if I am using a decent kind of glass, right? So how I start to manipulate these is I might go to my southern windows, assuming that this is a view that I really do want to have quite a few windows on, and I can narrow down my selection. You can see that really having shades, again, in this particular location, this particular setting, shading devices don't make a big impact, but the quality of glass does. So let's go ahead and do those changes right here. And you're seeing it's not making a big change here. These are smaller incremental changes. And depending on the size, the amount of surface area, that might be what you see. But we do want to start thinking about this information at any given site based on, how does my exposure in each one of these particular elevations work? How does it impact the energy performance? Really important. Now, when we switch to more of the building envelope, we can see that there are definitely a larger impact. So doing something like saying my construction type is going to have an R38 wall system, that has a significant impact. The roof construction, typically in the Midwest, we see an even more dramatic impact on the roof construction. Out here in California, not as much. So let's just drop this to, let's say, an R15, which kind of blows my mind. I'm used to like R60, R50, something like that. And infiltration, yeah, we can tighten that up. We could say code-wise, what we specify is going to be a fairly tight kind of system. Next, we can go to lighting efficiency, daylighting controls, and plug load efficiency. So this is how efficient the different things that we have are going to operate, including if we put occupancy sensors within the rooms for lighting. And I believe this is, yeah, occupancy controls. So I believe that is HVAC as well. Then when we look at HVAC, the type of HVAC system makes a big difference. So let's just go ahead and slide that down. It's a very, very small building that I'm working on, so I have no qualms about spending a lot of money on a solid HVAC system that's going to run very efficient. And then, people, we make a huge impact how often the building is going to run with people in it. If we're 24/7, if it's always occupied, it's at one end. This is a residence, and it's designed for young professionals. So, I'm going to assume that they're there not all the time, half the time, probably. The last set of panels that we get into are for photovoltaics, for our solar panels. And in particular, I think the most interesting thing is looking at surface coverage, how much we can save if we look at a 60% coverage number. So now we're starting to creep much closer toward where that 2030 building challenge is. So if I come all the way back up to the top, you can see that we are inching this towards that 2030 number. And I do know that, if I come back down and look at photovoltaic panels that have a 20-year payback on their efficiency and a fairly high efficient panel, now we're actually in the green, and we're actually putting energy back into the grid. In this particular design case, this is to be a standalone, off-the-grid kind of structure. So, we're not necessarily putting it back into the grid, but we're putting it back into the bank of batteries associated so that we know that ideally, in good conditions, we have energy in reserve at the end of every 24-hour period. So that's the basics of building a massing model in Revit, uploading the simulation to Insight, and manipulating these Insight panels to start optimizing your design's performance.